Steelmaking. It's a process that can be described as amazing. Like no other substance, steel has changed our world. It has allowed us to expand frontiers, go faster, live longer. It's an industry where product quantity is measured by the millions of tons, but quality is measured by the millionth of an inch. Skylines around the world are a testament to the strength of steel. The Golden Gate Bridge in San Francisco is a bold reminder of the durability and beauty it creates. And steel is evolving. If the Sears Tower in Chicago were erected today, it would require 35% less steel than when it was built in 1974. The creation of skyscrapers or bridges requires tons of product. Today it also requires microscopic precision. The very atoms of a beam of steel paint a picture of its strength. It's a view into this world that allows for precision. Scanning electron microscopes analyze structure and check the steel's cleanliness. Common impurities or non-metallic inclusions can affect steel quality. The smallest inclusion is now visible to the human eye. A spectrometer measures the chemical composition by analyzing just a few layers of atoms. Creating today's new steel requires manipulation at the molecular level. New high-performance steel allows a jet pilot to reach new heights, a surgeon to perform a delicate operation. It's the solid rocket booster casings that allow shuttle astronauts to explore new frontiers, and the roller coaster ridden by a child. Indeed, a lot rides on steel. And there are now more than 2,000 steel specifications relating to strength, shape, gauge, and coating.
People think of steel as being either a coil or a beam, those kind of things. That isn't what steel is. You know, steel is furniture and automobiles and appliances and computer chassis, and 75% of the grades we make for automotive, we didn't make 10 years ago. The ability to produce all these different grades and all these different shapes and sizes and tolerances is, to me, a direct result of the technology that we've developed.
Science has changed the quality of steel. And today, automation and intelligent process control allow for the consistency that's ushering in a new age of design.
You can repeat the process to the point that every piece of steel coming off is the same. So when you design a Sears Tower, for example, you don't have to allow for variations in strengths of steels because it isn't there anymore. It's consistent, consistent, consistent.
Steel is also consistently recycled. More steel is recycled each year than all other materials combined. It saves the energy equivalent to electrically power about 1/5 of U.S. households for 1 year. Steel has no memory. This means that once remelted and refined, one steel product can show up as virtually any steel product.
Steel is the world's most recycled material. In North America alone, last year we recycled almost 20 billion cans, 13 million cars, and 45 million appliances. So those appliances you put out, that car in the junkyard or the cans you put in your curbside, ends up going back to the process and becoming new products.
Once they arrive at a junkyard, cars are shredded. Because steel is magnetic, pieces of steel are easily sorted. Through recycling, these old cars will go on to become steel beams, appliances, or a bridge span. This is accomplished by putting the steel back into the steel-making process. This electric furnace has just melted 150 tons of used cars. It's a form of recycling not seen by many. 60,000 amps of electricity are sent through carbon electrodes. The electricity and oxygen transform the scrap into molten metal in less than an hour. This is just one way to make steel. Steel is also created using the basic oxygen process. Both processes combine iron and steel scrap. Temperatures during the process can reach more than 3,000 degrees Fahrenheit due to supersonic blasts of oxygen and other fuels. Oxygen helps remove many of the impurities, allowing recycled steel to become a new product. Once a ladle of molten steel has been produced, it must be refined to the exact chemistry, gas content, and temperature requirements for its new use. This is done at the ladle refining facility. Carbon electrodes produce electric arcs reaching 10,000 degrees. This quickly heats the steel. Selected alloys are added to alter strength and other properties. Once steel is refined, it can take many paths. It may be cast into individual pieces or continuous ribbons. The creation of flat-rolled steel begins at the continuous casters. These operate 24 hours a day, casting many heats in an uninterrupted sequence. Here, a ladle of refined steel is moved to the caster turret. The turret holds 2 ladles, which allows for continuous casting. The turret rotates over a bathtub-like container called a tundish. Laser sensors help lock a ceramic tube or shroud into position. This serves as a funnel for the steel. It also limits the steel's exposure to air, which can cause impurities to form. From the ladle, steel flows into the tundish, then into water-cooled copper molds. At the bottom of the casting machine, steel slabs emerge and are cut to precise lengths. These slabs will be transferred to a hot strip mill for rolling. At the hot strip mill, slabs are rolled to desired width and thickness. Precise control of speed and cooling is critical, not only to control size, but in controlling microstructural changes that give steel desired properties. At this mill, the strip is now reaching speeds of 30 miles per hour. At the end of the line, the strip is rolled into a coil that can weigh as much as 20 tons. The coils can be sent directly to manufacturers, but most will go through a variety of finishing processes first. These prepare the coils for use in cars, appliances, or home construction. New technologies allow the elimination of process steps. Here, a thin slab caster combines the continuous caster and hot strip mill into one step. This produces a piece of steel that is about 2 inches thick. It is continually heated and transferred in a shuttling furnace. It never cools, which saves energy. Because the slab is thinner, much of the rolling process is eliminated, saving time and energy. Although steel is made using equipment costing hundreds of millions of dollars, a pound of steel costs about the same as a pound of potatoes.
If I'm a consumer, I'm looking for 2 things: the best product at the lowest possible price. And I think that's what we're giving them right now. And if you look at, steel pricing over the last probably 15, 20 years, it hasn't changed.
Flat-rolled steel is just one portion of the steel market. Bar and billet steels are created much in the same way as flat-rolled sheet, but they are not cast into slabs. Instead, they are usually cast continuously in smaller, square-type sections called blooms or billets, or into larger individual ingots. Certain products call for these types of steels.
Some of the crankshafts that we supply steel for can be as large as a person's desk, and therefore you need something starting with that size in order to forge that component from.